Okay. Second to the last math video before your SOL test. And so we're going to be going over some questions that you had for homework last night. I hope that you downloaded it and tried it. If you didn't download it, try it, then watch the video. You should be at the point where your stress is starting to lower because you should be just about done with a lot of the stuff for your other classes. Okay, just to put that out there. Remember, the calculator is your friend, but not your guide. It's just a resource. Remember, operator error makes a big difference in our calculator use, so just try to remember not to believe everything the little piece of plastic spits out. Because it's not a sentient being, it doesn't have logical thought. It's not going to catch your mistakes for you, only you are. Okay, 3 rectangular prisms have the same base area but different heights. As the heights of these prisms increase, the volumes increase. Identify the dependent and independent variables in this situation. We have seen this question before during the school year. A lot of these questions have been kind of mixed into the different things that have come to us from the city and different things I've done with you. We're looking at the independent and the dependent variable, and the important part is right here. As the heights of the prisms increase, the volumes increase. So in other words, the volumes depend on the heights. If the volumes depend on, the volume is the dependent variable. So the volume of the prism is the dependent variable. If the volumes depend on the heights, the height would be the independent variable because that's what's causing the change. Alright. Independent, dependent variable. One depends on the other. Take your time, think about which depends on which, and you'll be able to find it. Next question. Some of these are super fast, so I'm going to try and get through most of them before I have to come to see you at school today. Negative relationship. That means we're looking for downhill, and the only one that has a downhill relationship is this one. If you also look at the what these are, number of states in the country since the year 2000 hasn't changed. Of course, if we started at like 1800, it'd be a tad different. All right, so that's a constant. This one is no correlation. Text messages sent daily. The age of the person and the number they send. I completely disagree. I think there'd definitely be a correlation there, but okay, whatever. And then here, the weight of a vehicle and the price of it. So the heavier the vehicle, the more expensive it is. I definitely agree with that one. So positive, none, constant, negative, that's what we're looking for. Time and the amount of water in a container, I guess it must be leaking. Stella has some colored cards that are the same size and shape. The probability of randomly selecting a blue card is 20%. We're not used to seeing probabilities as percents. So real quick, I'm going to think about that 20% in two other ways. I'm going to think about it as a decimal, which is 2/10, and I'm going to think about it as a fraction. Now, I'm not going to expect you guys to just know that 2/10 is 1/5. You probably should by now, but you could write 2/10 and then simplify it to 1/5. But there's that first one. The probability of getting a red card is 30%. I'm going to put that down here, 0.3 or 3/10. What's the probability that she'll randomly select a card that is not blue, replace it, and then randomly select a card that is red? So the fact that we're replacing them means that we have two separate probabilities, and we aren't going to have to worry about the second one in terms of the first one already happening. That's the replacement part. This is the part that gets a little bit tough, though. Not blue. If you have a 20% chance that the card will be blue, then you have an 80% chance that the card will not be blue. And then we already know for red that it's 30%. But we can't multiply 80 times 30 because that's not what we're doing here. That's not how we deal with percents. We would change them either to decimals or fractions. And probably it looks like the decimal is going to be the easiest. Because the fractions, I know I love fractions, but if you look at our answer choices, they're in percents. It'll be easier to go back to percents from decimals than it will be from fractions. So 0.8 times 0.3. Well, 8 times 3 is 24. So 0.8 times 0.3 is 0.24. 0.24, 24%. So C is the correct answer. I have two cats playing nearby that seem to want to knock things over and make noise while making a video. Just to warn you. Hey, Pod. Okay, let's get to the next one. More probability. Lawrence has these tiles that are the same size and shape, 6 blue, 9 green, and 10 orange. What is the probability that Lawrence will randomly select an orange tile, not replace it, then randomly select a blue tile? So this time we are not replacing. So orange, then blue. So we want the probability of orange, no replacement, blue. So probability of, first of all, what's the total? 6 and 9 is 15, and 10 is 25 total. So the probability of an orange is 10 out of 25. But I'm going to simplify that by dividing them both by 5, getting 2/5. Now the probability of getting a blue, there are no longer 25 tiles, there are 24. And there are 6 blue tiles. And 6 over 24, well, that's 1/4. So I'm going to simplify that there. And then I also notice 2 and 4 have a common factor of 2. So I'm going to divide both of them by 2. 1 across the top and a 10 across the bottom. 1/10. 1/10 is my answer. Now, they've added another level of difficulty to this because they want you to plot the probability on the number line. And again, I know we've done this question before. We've done this question. But not all of you remember it. Trust me. Because not all of you did it. Alright. Oop. I didn't mean to move that. Sorry. 1/10 will be right here. And so what the computer would let you do is actually click on it and plot a red point. And that's going to be that part of the directions where I say only the pointer tool can be used to answer a question. Okay, but 1/10 is 1/10 of the way from 0 to 1. Let's zoom that back out before we go on. Okay, onward. The real number system. I love this one because this one really gets you a chance to really show what you remember. So the tree diagram is one way we've done it, but we've also done this Venn diagram. And the entire thing is our real numbers. Most of you very quickly are going to be able to tell me that our irrational numbers goes right there. Let's color code these a little bit. Let's make that red. So my red one would go right there. Can I erase this arrow that I drew? Yeah, let's do that. Okay. Let's, right, so then we have to start thinking about, oh man, I don't remember which is which. I don't remember which is which. Don't panic. Think about what's most specific to least specific. The least specific one is in the middle. That's your natural numbers, because that's the one that's just 1, 2, 3, 4, and up. Your next one would be the one that adds on to that group. That would be your whole numbers, because all we add, remember, is the number 0. Now, the next thing we do is we add our positive and negative whole numbers. That's our integers. So no pieces of a number yet. So the category with all the pieces, all the number bits, the decimals, the fractions, that's the outer one. That's rational numbers. And that, guys, that's the one we usually get confused about. You're pretty comfortable working your way up through here. You're pretty comfortable over here. This is where you get confused and you end up sort of going, wait, no, maybe it's somewhere. Remember, rational and irrational. That's the way it's broken up. If you think about your tree, and the tree works for you, you've got real, you've got rational, which is actually Q, and then you've got irrational, which is I. And then from there, you've got integers, whole numbers, and natural numbers. So if you think about it, the tree diagram and this Venn diagram are really just the same thing, slightly different format. Composite figure. This will be the last one I do before I go to work, and my video is about halfway done, almost halfway done. So a composite figure, and we're finding the area of the figure. I see in this figure one triangle and one rectangle. So I was trying to figure out what color I wanted to use. And there's the distinction between the two, right there. So our rectangle is 3 by 13, and that's easy, that's 39. Multiplying length times width. Our triangle is a little bit tougher. We know its height. Its height is 10 right here. And its base, there's the 3 in the middle, and then 2 on either side. So 2 plus 3 plus 2 is 5, 6, 7, 8. So 1/2 times base times height. Half of 8 is 4, and 4 times 10 is 40. So 39 plus 40, uh-oh, I made a mistake. Because it's not 8, it's 7. Haha, joke's on me. Thought you'd catch me in another mistake there, did you, children? No dice. I caught it. Kinda. Oh, that's right, I can't erase once I switch tools. Okay, so Can't do half of 7. Let's do half of 5. Half of 5. Or, sorry, half of 10, which is 5. Wow. Most of the comp needs are coffee. 39 and 35. It's very interesting. Study music. Thank you, Apple Radio, for this odd interlude. So 30 and 30, 60, plus 9 and 5, that's 14, so 74. 74? Yep, there it is, D. All right, guys, we'll do the rest of these. I'll do the rest of these at work. You do the rest of these by continuing to watch the video. Okay, giant editing jump. Now I'm at school. So just a quick note before we move on to the next one. My mistake and then having to go back and look at it again, that's exactly the kind of thing I want you to think about when you're taking your SOL test. You're not perfect. You're going to make a mistake here and there, just like I just did. So rather than freaking out and getting confused and just guessing, stop, go back, and look at it again. Obviously, my phone's ringing. Hold on. Okay, another editing jump. Just again, check, check, check back behind yourself. Let's do another one. Xavier drew a triangle, XYZ, on a coordinate grid as shown. Here. He plans to dilate this triangle about the origin by a scale factor of 3 to create triangle X prime, Y prime, Z prime. Plot 3 points on the grid that represent the vertices of triangle X prime, Y prime, Z prime. So this has just been one big old video full of editing jumps, and that's okay. No biggie. I'm going to try and finish the rest of this before I have to go off to lunch here in a couple minutes. So if we're dilating this triangle and we're dilating it about the origin, that means we're using a scale factor of 3 by multiplying all my coordinates by 3. So if I have 1, 1, when I multiply it by 3, I'm going to use 3, 3. I have 3, negative 1. When I triple all of those, we're going to get 9, negative 3. And finally, when I take negative 2, negative 1, and triple them, we're going to get negative 6, negative 3. And those are the 3 points that I would need to graph on my coordinate plane. Negative 6, negative 3, right there. Kind of exaggerating because it's hard to draw a point that's right on there. I'll make my writing tool a little bit bigger. 9, negative 3. Should be right there. That's a little bit better. And then 3, 3. And we get a triangle that is 3 times larger than the original. So dilation, making larger or smaller by a scale factor. And what we had to do was multiply. Ms. Wright's 2 cooking classes are making a total of 60 sweet potato pies. Each pie requires 2 1/4 sweet potatoes. Her first class makes a third of the total number of pies needed. So before we keep going, they're making a total of 60. They made a third of the total, so they made 20 sweet potato pies. Exactly how many sweet potatoes will her second class need in order to make the remaining pies? Well, you have how many pies left? Well, you got 40 of them left. And if each pie requires 2 1/4 sweet potatoes, that's 40 times 2 1/4. 40 times 2 would be 80. 40 times a fourth would be 10. We need 90 sweet potatoes. You could also do the math by making it 2 1/4, 2.25 times 40. And I'm double checking with my calculator. 2.25 times 40 is indeed 90. So they need 90 sweet potatoes to figure that out. So that was a multiple step problem. Remember to think about using your understand, plan, solve, and then check. Okay, if I have 90 sweet potatoes, is that going to make enough? Well, if I take 90 and divide by 40 pies, I do get 90 over 40 does give me 2.25. So that's 2 1/4 sweet potatoes per pie. So that makes sense. Okay, just a couple more. The stock price of a company was $28. The stock price fell to 60 cents. It fell to 60 cents. So from $28 all the way down to 60 cents. That sucks. That's a huge decrease. So we want the percent decrease in this stock. Now, clearly, it can't be 114% decrease because you can't have it decrease more than it actually is. Then they'd actually be paying you to buy the stock. They don't do that. So we're going to find the change, and it's change over original. And that's what's true always for any percent change problem, change over original. So the change here is $28 minus 60 cents. So $28 minus 60 cents gives me $27.40. So it's a huge percentage of the original. So $27.40 is the change over the original 28, equals x over 100. Remember the usefulness of proportions, guys. In a proportion, all you got to do is cross multiply and divide, and you've got your answer. So 28 times x is 28x. 2740 times 100 is 2,740. Divide both sides by 28. And we get 97.8. So when we round it to the nearest percent, x is approximately equal to 97.8. That's 98%. Looks like we only have 4 more questions in this video. Let's see if I can knock them out. Okay, so this is a evaluating expression question. And unfortunately, they gave me a negative and they gave me a negative decimal. So 2 times, and we're going to plug in our decimal, plus 2 times negative 1.2 squared. Now the first and most important thing to remember here is your order of operations. The second thing you want to remember here is how exponents work. If you know those 2 things, you're going to be fine. When I square the negative 1.2, I get positive 1.44. I'm going to bring that down, and I'm going to bring down the rest of the problem, although I can go ahead and do the math inside the parentheses at the same time and get 3.8 right there, because neither of those had any effect on one another. It was inside the parentheses and an exponent, and then there's addition separating them. Now I need to do the multiplication. 2 times 3.8 is 7.6, and 2 times 1.44, or 1 and 44 hundredths, is 2.88, or 2 and 88 hundredths. And when you add those together, you're going to get 10 and 48 hundredths, or 10.48, which is C. So plug and chug. Got to know your order of operations, and you have to know that when you square a negative, you get a positive. That's what's going to make a big difference here. And then there were 3. So this is a great question because it requires you to know a whole bunch of stuff. Vertical angles, adjacent angles, supplementary angles, and complementary angles. Let's start with the vertical angles. We want the ones across from one another. So across from one another are going to be 1 and 3. Those are the only ones that are across from one another in an X. 1 and 3. So we put 1 here, we'd put 3 here. 4 is adjacent to only one numbered angle, and you notice they did this on purpose. They didn't number the right angle over here on purpose. So 4 is only adjacent to 3. 3 is supplementary with the angle that makes it add up to 180 degrees. Let's switch colors. 3 is only supplementary with angle 2. And then finally, for complementary angles, we want to look at the right angle. Let's use blue. The right angle, which is the 4 and the 3, which is adjacent to, supplementary to that other right angle there. So 3 and 4 are complementary. And so that means that it appears that you might use each one more than once. Oh, well, look at that. I didn't even read my directions in our fancy little gray box we never see. Got to make sure we read those. Click and drag the correct number to each box. A number may be used more than once. So the 3 was used twice. So 1 and 3 vertical. 3 and 4 adjacent. And that's the only one that can go there because 4 is also adjacent to the right angle that's not numbered. 2 and 3 are supplementary. 3 and 4 are complementary. This one and one more, guys. So let's talk about this one with the views. I've always wished that we could actually turn the 3D figure views that they give us and actually look at them by turning them ourselves, which would be awesome. So we're looking for the front view, and I love that it's color-coded. We wanted to have 2 blocks in this this left-hand, 4 blocks in the left-hand row, or column, excuse me, and 2 blocks in the right-hand column. So this one has the 4, but it has 3, so that can't be it. This one here has 4 and 2, that's probably our answer. This one has 3 and 4, so that's not it. And then this last one here has 4 and 2, so that one works as well. So it turns out this is a multiple correct answer. Man, your teacher really needs to start remembering to look up here for these darn directions. You must select all correct figures, so there were 2 on this one. And we're only looking at that front view. And remember to look for the color coding. Okay, and don't rush through these, even though you think they're easy. Sometimes we make silly mistakes when we think everything's easy. Okay, Leslie built a walkway around a rectangular garden as shown. The walkway is the same width on all sides of the garden. What is the perimeter of the garden? So we want this distance. So we have to utilize the information they've given us and find that distance. So if I'm talking about this distance on the garden, we have to take off the, I've been talking to my sister. My sister's from Massachusetts. Sorry, we have to take off the 3-foot walkway on each side. So that means that we're really, for this length, it's 30 minus 6. So the length is actually 24. Okay, so the length of my garden is 24. The width of my garden is that 20, and again, take away the 3 on each side for the walkway. So that's 20 minus 6, that's 14. So this side is 14. Then I just have to think about what perimeter is. Perimeter is 2 of the length, so 2 of the 24s, and 2 of the width, so 2 of the 14s. So 2 times 24, that's 48. 2 times 14, that's 28. 48 and 28, 76. D is the correct answer. And that concludes your third SOL review video. I will have one more for you on Monday night to get ready for your test. And in any case, I'm super proud of everybody, and I know that you have it in you to do well on your SOL. Have a great weekend. I'll see you guys in class.